Welcome, everybody, to the Daily Space Weather. Smash-O here, coming at you from the Smash News Network, least busted name in news. Lots of stuff going on in terms of space weather. Lots of plasma on the way to Earth at the moment. Only a minor little series of effects happening so far. We'll get to it. We're looking at the sun here in 171 angstroms plus colorized magnetogram. Most of the activity coming from this sunspot down here. Sunspot 3068. And here's a colorized magnetogram. We do have another sunspot group rising over here. It's pretty small at the moment. We have a very, very high likelihood of additional large solar flares and coronal mass ejections. We'll get to that as well. Here's your solar intensity gram from SDO. This group up here gaining some complexity as well. Some additional umbra forming in the northeast as well as the southeast in the past 24. Brief look at volcanoes to see a downtick in volcanic activity. Semeru continues to explode. 13,000 foot ash plume from Semeru. Sangay and Revenador both exploding in Ecuador. Flight level 190 from Sangay, 19,000 foot ash plume. Flight level 140, 14,000 foot ash plume from Revenador. And Sabancaya in Peru also exploding, 22,000 foot ash plume. Those are the only volcanoes on the list. Only 4 volcanoes. Downtick in volcanic activity since yesterday. Seismic activity not super high either. No major quakes here over the past 24 hours. Check it out, only 2 7-magnitude quakes in the past 90 days. The largest was a 5.6 at Japan. There was also a 5.1 at Russia. That's out in the ocean there, actually kind of close to Japan too. And we had a quake come in as we created the video here. And a 5.0. So a 5.1, a 5.0 at Russia. All of the largest quakes there in the same location. Papua New Guinea also had a 5.0. So most of the seismic activity here happening in the Western Pacific. Some quakes in the Aleutian Islands as well there, south of Alaska, like this 5.0. And there's the largest quake of the past 24 coming in at 4:24 this morning on August 17th. A 5.6 off the coast of Japan. So here's the last 24 in our house favorite wavelength, 171 angstroms. And there were indeed additional coronal mass ejections sent out in the past 24. Here's some imagery of that. That's the last 24 and 304 angstroms, plus the LASCO C3, that's the blue region, and the LASCO C2, the red region. Those things are out at Lagrange point 1, orbiting that gravitational equilibrium point with their coronagraphs. And again, you can see some additional CME material there headed out into space. Doesn't look like it's earthly directed. The 10.7 centimeter radial flux has come down to 129 solar flux units. If you're not familiar with the radial flux, it's the most proportional data set we have to sunspot number. And if you compare the black line to the light red line here, that's the radial flux versus the sunspot number. And you can see how proportional they are from that 1-year graph. Space Weather Enthusiast dashboard here, forecasting geomagnetic storms later in the day today, early in the day tomorrow, all the way into Friday. So expecting geomagnetic storm conditions into Friday. Finally ending in some geomagnetic unrest. It's from multiple coronal mass ejection impacts as well as a coronal hole high-speed stream. So you may be able to see aurorae at mid-latitudes here, maybe early in the morning tomorrow. So keep your eye out if you've got clear skies. There may be a KP7. That's the NOAA forecast from the Space Weather Enthusiast dashboard. So here's the last 4 hours of magnetohydrodynamic pressure modeled by the Space Weather Modeling Framework. That's out to about 12 Earth diameters, and we did see an increase here in the pressure. A little uptick in the solar wind speed has been the latest change in the solar wind data. So that's the last 4 hours, Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. And you'll see a little uptick here in ground magnetic perturbations as well. It's showing you changes to the Earth's B field, the field going through the magnet. You can see that little uptick there in geomagnetism toward the end. That's a representation of an increased solar wind speed. So the KP index only at 2 at the moment. And so far, the coronal mass ejection strike has been pretty minor, what you'd call a glancing blow at best. So likelihood of aurora not super high at the moment. Again, if we are going to see some, the NOAA forecast at least is for a possible KP7 early tomorrow. We may see aurorae as far south as Pennsylvania. We're located in Lehigh Valley. And we may have to get up early and take a look. But there's the current aurora forecast. Pretty weak at the moment. So let's move to the real-time solar wind next. And you can see this signature of a coronal mass ejection strike. Starting out with a dip in the plasma temperature here, this bottom pane, and a sudden increase in the magnetic field. So you can see there, oh man, the magnetic field went all the way up to 18 nanotesla. But we didn't get a negative BZ, so the vertical component is that red line. And when you see a strong signal to the negative, that's when we see strong induced currents on planet Earth. At the moment, no significant signal there in negative BZ territory. And the field weakening a little bit too. So anyway, current conditions are solar wind density about, I'll say about 12 protons per cubic centimeter. Solar wind speed just under 500 kilometers per second. Again, we're expecting multiple coronal mass ejection impacts, at least one more, as well as a coronal hole high-speed wind stream. So those might interfere with each other in terms of signals. And let's move to the magnetic data. So here we saw a huge divergence happening between the GOES 16 and the GOES 17. Keep in mind, folks, these M's stand for midnight local time for the satellites. So the GOES 16 and GOES 17 are geosynchronous near equatorial orbiting satellites. And a very big drop-off there in the GOES 17 reading, around midnight local time for it. And let's take a look at the heliospheric current sheet while we're talking magnetics. Earth remains in a South Pole-oriented magnetic field. And we've got some significant South Pole-oriented coronal holes as well. So here's our line of sight field plot showing the Sun's B field in blue. And let's move to coronal holes. You can see lots of South Pole-oriented coronal holes. And the South Solar Polar migration is ahead of the North. So you can see almost no South Pole magnetism at the South Heliographic Pole. So its migration is well underway, whereas the North Solar Polar Field, you can see, is still somewhat fixated at the North Heliographic Pole. So it's behind, which means we've got a lot of solar cycle to continue. Another point, you can see that it is starting to migrate because it is kind of on the opposite side of the Sun at the moment. You can see it's kind of rotating out of view here. And we've got two different extreme ultraviolet spectra to show you here. This is 193 angstroms. That's ionized iron. Great imagery there of that large transequatorial coronal hole, from which we are expecting an increased solar wind speed in the coming days. There's 211 angstroms. And when we see the coronal hole wind stream arrive, we can expect an increase in the solar wind density, followed by a drop-off in the density and an increase in the solar wind speed. That's the signature of a coronal hole high-speed stream. And let's move to sunspots. And before we talk about sunspots, let's pause for station identification. Thanks for leaving a comment, Tinman1057, and good morning to you as well. Welcome to the Smash News Network, least busted name in news. So we've got quite a few named sunspot groups here. This group here needs a name. I think this group here needs a name. So, but the most exciting one is, I think I called that 3086. That's actually 3078. That is the main offender when it comes to solar flaring. It's produced a number of M-class flares there. Sunspot 3078. I would expect additional large solar flares. 3079 is setting. It's quite magnetically complex as well. And as our regular viewers are well aware, sunspots on the limb much more likely to produce large solar flares. Let's take a look at some sunspots here in the SBO continuum wavelength. And we'll zoom in. That's the last 24 hours. Again, likelihood of large solar flares very high. We've got at least two sunspot groups down here that need names. This group up here has gained magnetic complexity. It's grown. So all of these factors increase the likelihood of solar flares in general and large flares. Here's your SDO magnetogram for the last 24 hours. And let's move on, since there is a lot more to cover. So you can see the X-ray profile here has come up a lot in the past week. Here's the 7-day chart. You can see we were down in a B-class background level. Now we're moving toward a C-class background X-ray profile. A couple flares coming in here as we did show prep. And a number of M-class flares on the past 3 days. So major uptick, by the way. If you want to watch the effects on planet Earth from solar flares, check out the deabsorption region predictions. That is the D layer of the ionosphere being modulated by incoming X-rays, causing radio signals to end up blasting out into space instead of refracting back down to Earth where they can be picked up. Those radio signals being sent to extraterrestrials instead of to the earthly targets. And that's the immediate effect. It only takes about 8 minutes for the light to arrive from the sun. When you see that happen, that is 8-minute-old photons. Great wavelength to view X-rays is 131 angstroms. And you can see some flaring again happening from sunspot 3078. .94 angstroms is also a great wavelength to view solar flares. We're going to show you a spectacular zoom in here, since here at the Smash News Network, least busted name in news, we show the most detailed imagery of the sun and the most comprehensive space weather in the world. So we didn't really see any significant relativistic particles there. Keep in mind the GOES 16 is orbiting the Earth. It's well inside the Earth's magnetosphere. No major spikes there in the GOES proton flux. And here's a star chart. If you look up before dawn, if you've got clear skies, you might see Jupiter, the Moon, Mars, and Venus all out there near the ecliptic. That's the yellow line, the path the sun will take across the sky. The blue line here is the galactic plane. And let's do a solar system forecast. Venus is headed to the opposite side of the solar system from the rest of the planets, and Mercury is joining the other 7 planets on this side. Here's your 1-week forecast. We'll have a crescent waning moon at the time when August 24th rolls around. Now we've got some coronagraph imagery. Here's yesterday's imagery. Again, additional CMEs happening. They don't appear to be earthly directed. They're off to the south as far as we can tell. And here is today's imagery so far. That's 23 frames. We're going to show you some more coronagraphs here. We're going to show you the Soho Lasco C3 as well as the Stereo A coronagraph. But first, we invite you all to enjoy the Twitch app, twitch.tv/SmashoMash. Perhaps install that. It'll alert you when we go live. Make sure you follow us on Twitter. If you don't have an account, follow us on Twitter. Make an account on Twitter. You'll see things you can only see on Twitter because we only have so much time to share other people's content and so forth. Twitter.com/SmashoMash. You can find links to it on the homepage at smashomash.com as well as below this video. And welcome to the Neo-Renaissance. And the reason we started covering the sun in such great in-depth, in such detail is because, well, back in the mid-90s, I realized that there is a hole in cosmology, and that hole is largely as a result of a lack of understanding of heliophysics. If you take an astronomy course, you may realize that the understanding of the sun is largely glossed over. There are various features that are not well explained by what you'd call the concordance model of stellar evolution. And the sun is the basis for us believing we understand what's going on in distant galaxies and so on. So that's part of the reason why we started doing the videos, because, hey, when you immerse yourself in the data, science is weird like that. You may end up with answers to questions not asked, which is certainly what's happened, which is why we're in the process of explaining plausibly the mechanism that underlies the solar sunspot and solar polar field reversal cycles. So support the channel by clicking our links. Support your own health by becoming a member of SureMed, the American Better Health Organization. All sorts of fantastic discounts, teledoc service, phone counselors, even virtual veterinarians. All as part of just a base membership. And for example, if you do the Plus membership, you get accident insurance thrown in. Feel free to give me a call or send me an email. Contact information listed right there on the page. Again, you can find links to that on the homepage. If you haven't checked out the merch shop, links to this as well as on smashomash.com. Also links below this video. These are sorted in order of best selling. Today's featured product is not political at all. It's MANSA, which stands for Make America Not Suck Again. By the way, be inspired to save 25% by using the promo code INSPIRED through Friday, August 19th. Promo code INSPIRED will save you 25% on clothing. And I'm wearing actually 2 pieces of merch at the moment. MENSA, which stands for Make Earth Not Suck Again, and MANSA. It's up to you and me to make Earth not suck again. So we figured we would create such a thing. It's got the Constitution in the background, and it says Make America Not Suck Again. It's up to you. Yeah, it's up to you, folks. Once again, save 25% on all clothing by entering the promo code INSPIRED on checkout. It's completely apolitical. And by the way, I've never been associated with a political party, probably never will be. Not Republican, not Democrat, not socialist, not libertarian, none of the above, because, well, frankly, their stances are just not nuanced enough. Make America not suck again. It's up to you. Again, links on the homepage to that. If you want to support the channel via subscription services, become a gold or silver Smash Team member. Give Smash staff a raise. Help us out by sending us a few bucks per month to continue to create the content. Make sure it remains publicly visible and free for all to view. There is a credit crawl coming back. You can also support us via Patreon. Thanks to everybody who has over the past 5+ years of making the most detailed space weather videos in the world. Smashomash.com/SmashTeam. Join at the gold or silver level to support the channel. If you refuse to do any of those things, at least press like and subscribe. Press the share button, share on your social media. If you're an influencer, hit us up. We'll be more than happy to appear on your channel and have you on ours. Press like, press subscribe, press the share button, and leave us a comment. Even if it's derogatory, we read them all, and we appreciate them all. Now, we paused our coronagraphs here on this moment because that is relativistic particles striking. So this is from a coronal mass ejection that happened only about an hour before that. And that means that those particles are traveling at about 1/8 the speed of light. And I just figured I would pause it there. That's the Soho-Lascaux C3 located at Lagrangian point 1. And those particles never really made it to Earth in a significant fashion. Keep in mind, the Earth is inside of a magnetosphere, and the Soho-Lascaux C3 is not. So I just figured I would pause that there for your viewing pleasure. We've got a bunch of missing data here on the Stereo A coronagraph, which I'll also show you as the Soho-Lascaux C3 plays, going from yesterday at 7:38 in the morning to 17:53, so 10 hours, over 10 hours of missing data there on the Stereo A coronagraph. Pretty unfortunate. And then another like 10 hours of missing data. So Stereo A, a little bit disappointing. Soho-Lascaux C3 there showing us good data. And again, we are expecting all or most of that ejecta to be missing Earth to the south. Now, we do expect additional coronal mass ejections. Likelihood of solar flares very high. Likelihood of coronal mass ejections also very high. Check out the size of this filament down here. Much larger than planet Earth. Huge filaments in the northern hemisphere as well. Again, likelihood of coronal mass ejections super high. Here's the latest imagery from the GOES 16 SUVI. And things calm for the past about 2.5 hours. Here's the last 24 hours from the SDO in the same wavelength, ionized helium, which is 304 angstroms. And let's blast through our bonus features segment. We separated our videos because of silly algorithmic nonsense and attempts to gaslight us by YouTube. We've put them back together to put all of our space weather and Earth weather in a single video. So now we're on the Satellites Community Dashboard, and we do see indeed some internal charging hazards continuing here. This is from high energy electrons building up on the inner circuitry of spacecraft. You can see some minor internal charging hazards here stretching all the way from Africa to the Central Pacific Ocean. Could cause some minor communications breakdowns, but not major ones. Electron flux here dipping as we forecasted yesterday, and it's typical of coronal hole high-speed streams as well as coronal mass ejection strikes to see the electron flux dip. Here's the forecast by NOAA. You can see NOAA expecting a little bit lower electron flux as well. There's the 1-year chart of the greater than 2 mega electron volt electron fluence from Solon.info. And let's take a look at the F ionosphere next. It's located at about 300 kilometers of altitude. This is the vibrational frequency data provided by Australian Government Bureau Meteorology. Megahertz are millions of vibrations per second. We'll also show the anomalygram. Quite a bit of blue on the map here. That's high frequency anomaly. And this scale is +3 and -3 megahertz. +3 through -3 megahertz anomaly from the 30-day median. There's the latest image. That's 1015 universal time ionogram, 1015 universal time anomalygram. Again, mostly high frequency anomalies showing up at the moment. Next, we'll show the total electron content forecast. It's the coupled thermosphere, ionosphere, plasmasphere electrodynamics. It's basically all the free electrons from ground level up to your GPS satellite. Now, those satellites are located about 12,500 miles of altitude in their geosynchronous orbit. They're right on the inner portion of the outer Van Allen belt. We do see a little bit of disorganization happening there. Some electrons making it rather far south in places like the southern Indian Ocean, the Southern Ocean, but most electrons here organized around the equator at noontime. So here's a diagram of what we're looking at. It's this area right here. There's a plasmasphere. There's an inner Van Allen belt. There's another plasmasphere. And then there's the ionosphere. Continuing on, here's your latest intensitygram and your latest colorized magnetogram. Again, this sunspot down here needs a name. That should get a name today. It's fairly magnetically uninteresting. This one up here, quite a bit more interesting. It's grown in the past 24. And of course, the most exciting sunspot area is this area down here, sunspot 3078. And the group that leads it, that's where most of the flaring has come from, and it is certainly beta gamma delta class. At the moment, here's the zoom out to the full disk. Again, likelihood of major solar flares and coronal mass ejections super high. Let's bring up one more composite view here. Let's do Iron Star today. This is 94, 335, and 193 angstroms. That includes yesterday and today's data. Spectacular imagery there from the SDO. Great view of the large South Pole-oriented transequatorial coronal hole system. And some flaring showing up there as well. And now it's time to move to the realm of meteorology, because it's a value-added service. I realized decades ago that, well, forecasting the weather was beneath me, but I figured I would bring it to the channel anyway, because, hey, again, it's a value-added service from the Smash News Network, least busted name in news. So one of the features of nullschool.net is that it'll show you the likely auroral ovals. And you can see they're looking pretty weak. Not a lot of folks on the planet likely to be seeing aurorae at the moment. It all has to do with the magnetic field orientation, that BZ component we talked about earlier. Let's get to the regularly scheduled meteorological information. Here are the surface winds of the eastern world. Shout out to our viewers from all around the planet and elsewhere. Thanks to earthly and extraterrestrial viewers. Here are the jet streams of the eastern world. A large kink in the jet stream there, in between Australia and New Zealand, making for warm temperatures in New Zealand. Warm temperatures being ushered into New Zealand by the jet stream. Here are the jet streams of the Americas. Cold temperatures being ushered into Pennsylvania and deep into the southern eastern U.S. Central Canadian air being blasted down by the jet stream. Here are the jet stream. Here are the surface winds of the Americas. Powerful low here in between Greenland and Iceland. You can see that counterclockwise rotation there. "47-mile-per-hour winds showing up. Here are the surface winds of the central world, Europe, Africa, and the Middle East. And the jet streams are where we'll end our coverage of nullschool.net's fantastic website. Nullschool.net's Earth wind map. It's just spectacular. Large anticyclone here over south-central Africa. You can see the counterclockwise rotation there. That is a high-pressure zone, likely featuring clear skies. Hey now. Next, your weather.gov map. If your county's lit, click your county. We've got some high winds here around the east coast of the U.S. Some gale warnings and some high surf advisories around New England. Again, if your county is lit, head to weather.gov, click your county. Excessive heat on the west coast. So here's your temperature anomaly forecast, since that's where most weather warnings are associated here with temperature, so we figured we would bring up a 72-hour GFS temperature anomaly forecast. Keep in mind it's showing degrees Celsius on this scale. And we're also going to show the jet stream forecast. So here is the 250 millibar wind forecast based on the GFS model. And you can see cold temperatures continuing in the southern in the eastern part of the country there as a result of that jet stream dipping way down and pulling Canadian air in places like Lehigh Valley and Missouri and Indiana and the Great Lakes states and so on. Those cold temperatures making it all the way down to Texas. Again, it's a 72-hour, 250 millibar winds forecast based on the GFS model. Next, we've got your UV index. And there you go. That's the highest UV index in the world. It's the portion of the planet where it's noontime. So one of the many features of windy.com is that you can look at the UV index. And there it is. Not surprisingly, the UV index is highest at the part of the planet where it's noontime. Continuing on to our NASA GOES lightning mapper, and there is the last about 10 hours of lightning. Arkansas featuring some heavy lightning, as well as Mississippi. And here's a real-time lightning map from lightningmaps.org. Next time you hear thunder, check it out, lightningmaps.org, powered by blitzertung.org. And we're going to zoom in here. Hey, Memphis, there's thunder rolling in. It's mostly to your south. Perhaps a great light show above those cloud tops if you're able to see. If you're on a skyscraper, if you're able to get a good field of view, take some video of those cloud tops. You may find some sprites, some green elves, blue diamonds, purple horseshoes, red balloons, or other lucky charms occurring above those clouds. Lightningmaps.org. It could save your you-know-what. Next, we've got your U.S. Doppler radar map. We've got your shortwave radiation satellite showing clouds and fog. And we've got the water vapor map. You can see a bunch of dry, massive air here. That's all high pressure, relatively speaking. This low here making its way across Arkansas and into Mississippi as we stream the video. And let's show the recap because we've got to get this video onto YouTube. Thanks again to everybody who's tuned in. That's our recap. We'll briefly zoom out to show all 50 states. Some rather heavy precipitation showing up there in southern Alaska. Here's your shortwave radiation map, 3.9 nanometer infrared radiation showing clouds and fog. And the water map. That's the water vapor showing all the water vapor, not just the clouds, but even the portion that's not condensed onto clouds. That should clarify things if your Doppler is not doing it, and we hope we clarify things when it comes to space and Earth weather. Thanks for tuning in. Congratulations on realizing that the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, and may that solar wind be at your back.